In this video, we'll show you how to conduct subjective comparisons with Subjectify.us. For this illustration, we'll perform a basic comparison of image upscaling methods using the Subjectify.us platform. Our comparison will involve three well-known methods: nearest neighbor, bilinear, and bicubic. We'll apply them to two test images at three upscale factors: 2 times, 3 times, and 4 times. Let's begin by logging into the Subjectify.us platform. The dashboard lists our existing projects. Since we want to start a new comparison, we'll hit the plus button in the bottom right corner. Let's name our project image-upscale. Since we're going to compare images, we'll choose the images option. If you're comparing video processing methods, you should instead choose the videos option. To start the project, click Create. The most important part of any project is the data you want to analyze. Therefore, we first need to upload that data. We prepared a dataset ahead of time using a simple Python script. The video description below provides a link to this script in case you want to review it yourself. For now, though, we'll just look at the structure of the dataset. This structure will help Subjectify.us identify what we're going to compare. For each test case, we have a directory, and each directory contains 10 PNG files, one for each combination of method and upscale factor, as well as one for the ground truth result. Let's look closer at these file names. Each one consists of two parts, separated by the @ symbol. First, the method name, and then upscale equals some value. For example, bicubic at upscale equals 4, or bilinear at upscale equals 3. The @ notation helps Subjectify.us to recognize upscale as a parameter, allowing it to generate more meaningful plots in the study report. For the ground truth result, we have no parameters, so we go with just the method name. No @ symbol is necessary. If the methods in your project have no parameters you want to compare, you can likewise use just the names without @. Both the Lena and cameraman directories have the same content structure. Now let's drag and drop these directories in the web browser. As you can see, the platform has detected that our dataset consists of 2 test cases and 10 methods. At this point, we can click the Upload button. Subjectify.us is now pre-processing the files we just uploaded. For image comparisons, the pre-processing is quick. For video comparisons, it may take a while depending on the size of the dataset. Next, we need to enter the task description that study participants will see. For our example project, we'll use the simple description: for each image pair, choose the image with the best visual quality. We must also select the number of questions each participant will answer. Since comparing upscale methods is easy, let's make it 30. We'll leave the number of verification questions as the default value. These questions help ensure the study participants make thoughtful selections rather than choosing random images. Finally, we need to set the verification questions. Our questions will assume that the quality of the ground truth result is always better than the quality of the nearest neighbor result at 3 times and 4 times upscaling. So for the first question, let's set Lena as the test case, with ground truth as the higher quality option and nearest neighbor at upscale 4 as the lower quality option. We'll add the other questions in the same way. As you can see, the image pre-processing is now complete. Finally, everything is ready and we can click the Start Comparison button to begin collecting participant responses. At this point, Subjectify.us is recruiting participants for our study. For this hypothetical comparison, the study report will be ready in a couple hours. For larger comparisons, the platform will take longer to create the report. Before we view the study report, let's take a quick look at the interface that the platform shows to study participants. Here, participants will see the task description and a download progress bar. When the download is complete, they can click the Start button. The platform shows the first pair of images and provides 3 options: left, right, or I can't choose. To illustrate how it works, let's answer left here. The platform then goes to the next question. Again, the left image has better visual quality, so if we were to continue, we'd choose left once more. The study participants answered these and the remaining questions in a similar manner. All right, our comparison is now finished and we can view the report. Here we can see a bar chart depicting subjective quality scores. The platform computed these scores from the pairwise comparisons using the Crowd-Bradley-Terry model. As we'd expect, the ground truth image has the highest score, but this chart is a bit hard to interpret because the methods aren't grouped by upscale factor. Since we use the correct naming convention, however, we can easily group the methods right here. The grouped results are much more informative. We can see a red line indicating the ground truth level and 3 other lines, one for each upscale method. The graph shows that the visual quality of all the methods degrades with the upscale factor. The best method is bicubic, in second place is bilinear, and last is the nearest neighbor method, which has the worst scores. Of course, all these results are pretty much what we'd expect since we only did an example comparison. Nevertheless, we can make at least one interesting observation from the graph. The quality of bicubic 4 times upscaling is better than nearest neighbor 3 times upscaling. The report interface also enables you to view individual charts for each test case. That's it. We've now completed our simple comparison and analysis. We hope this video has helped you to learn how to use Subjectify.us in your research projects.